My name's Graham Hammer. I'm a professor in crop science at the University of Queensland, and my research is focused on the development of crop growth and development models, mathematical models, to predict the growth and development of plants like sorghum, which is the plant you see here. So in essence, in a computer program, we predict what happens each day in terms of the leaves, growth of leaves, the growth of mass of the plant, the partitioning of that mass to these various organs, ultimately to the developing panicle you see here, which will have flowers and ultimately grain, which become crop yield. And so what we want to do is predict what happens to this plant over time, how does it grow, how does it develop, and ultimately what yield does it produce. We're particularly interested in this research in what happens if we can manipulate photosynthesis. And so photosynthesis is the process of fixation of carbon by the leaves, and it's critical to the growth and development of the plant. But what I want to start off with is thinking about how you move across scales. So photosynthesis is really happening at a cellular scale. Crop yield is really happening at a community scale, lots of these plants in a field. And the individual organism is really the level at which this is all integrated. So one of the main things we're doing with this research is looking at various ways of manipulating photosynthesis and the consequences of that on grain yield in crops. And when we look at aspects of, for example, rubisco activity, if we increase rubisco activity by up to, say, we can do that by up to, say, 30%. Then we can put that into this cross-scale model because we've got the photosynthesis functions at the cellular scale connected to the organism, connected to the crop, and we can say, well, let's change that rubisco activity and look at the consequence on a wheat crop or whatever crop over a number of years. And so we can run a simulation using the weather data for 50, 100 years and see what happens. And when we do that, we find that there's a significant effect, an increase in yield, but it's more in the better years than in the drier years. And in the better years, that can be upwards somewhere between 5 or more %. But remember, you're changing rubisco activity by more than 30%. So you're only getting from that 5% increase in grain yield. So it's not a one-to-one. And that's because of the complexities in the system in scaling from cellular scale to community scale. And the difference when you come back to lower yielding years is the advantage is only a few %. And that's because, again, of these interactions with stomata. So when you have drier situation, your stomatal control is regulated by the amount of water available to the plant. And so the enhanced rubisco activity isn't as advantageous to you because the CO2 influx into the plant is being restricted by effects of water stress on the stomata.